Module 5, Chapter 3.2, Quadratic Functions and Graphs. A function of the form f of x equals ax squared plus bx plus c with a not equal to 0 is called a quadratic function. Quadratic functions can also be written as f of x equals a times x minus h squared plus k, where the vertex is hk. The graph of any quadratic function is the graph of y equals x squared stretched or shrunk and shifted horizontally and or vertically. For instance, anytime we have a quadratic equation, we know the graph is going to be a parabola. Y equals x squared is our regular parabola. And then the 2x squared plus 4x minus 16, it's still a parabola. It shrank a little, it's a little bit skinnier, and the vertex has moved around. Rewrite f of x equals x squared plus 10x plus 25 in the form f of x equals a times x minus h squared plus k, and identify the vertex. Now this should be something like the circle formula we did earlier. F of x equals, actually this one is a perfect square trinomial. This is a perfect square of x. This is a perfect square of 5. 5 times x is 5x double gives us 10x. So we know that this one is going to factor automatically as x plus 5 squared. What that tells us is the x value of the vertex is this opposite sign, which would be negative 5. The y value of the vertex is the number out behind the square term, which there's not one, so that would be 0. Now, what if it's not already in a perfect square trinomial form? Well, what we're going to do is if they give us ax squared plus bx plus c, first thing we're going to do is factor out the a, or the number in front of the x squared, out of the x squared term and the x term. We always want our x squared term to have a coefficient of 1. Then we're going to set up the perfect square trinomial, leaving the space for the third term inside the parenthesis, and keep c out of the parentheses. Now to complete the square, you take half of the b term, or the coefficient of x, and square it. This number is added inside the parentheses to complete the perfect square. Now, if there's an a, we take this number, multiply it by a, and add the opposite of this number onto the end of the expression. Let's do an example. If we have f of x equals 2x squared plus 4x minus 16. First thing we're going to do is factor out a 2. So that would be x squared plus 2x plus, leave a gap. Now let's just go ahead and leave our minus 16 on the end. Now we're ready to complete the square. Half of 2 is 1. 1 squared is 1. So we're going to add 1 here. Now back in the circle, what we did is we said, well, if we added 1 here, we had to add 1 to the other side. We don't have another side here. So what we're thinking is if we add a 1 here, but because that's also 1 times 2, if we add a 2 to the inside of the parentheses, then we're going to subtract a 2 from the outside of the parentheses. Therefore, basically, we've just added a 0 by adding 2, subtracting 2. Now we're ready to go on the inside of the parentheses, factor that. So that would be x plus 1 squared minus 18. So from looking at that, this is what we call the vertex formula. The vertex would be, change the sign in there, which would be negative 1. Keep the sign on the end, so our vertex would be negative 1, negative 18. Let's do another one. Rewrite f of x equals negative x squared plus 6x minus 10. Same thing. We want to pull out the coefficient of the x squared, so that would be x squared. That becomes negative 6x, and leave your negative 10 on the outside. Let's complete the square. Half of negative 6 is negative 3. Square the negative 3 and we get a positive 9. This negative 1 makes this positive 9 a negative 9. So we're going to add the opposite. We're going to add a positive 9 on the outside. Now we're ready to complete this perfect square trinomial. X squared minus 6x plus 9 is x minus 3 squared. Negative 10 plus 9 would be minus 1. So we can look at this and say, okay, vertex is 3, negative 1. Now, remember that all graphs of quadratic functions will have the same basic shape as x squared. It's going to be a parabola. Now, some of the parabolas are going to open upward, some are going to open downward. What tells us is this number in front of the x squared. If the a term is a positive, then we know that our parabola will open downward. If the number in front of the x squared is negative, then we know that the parabola will open downward. Okay, now the graph of p of x equals a times x minus h squared plus k will always be a parabola with vertex hk. It will have an axis of symmetry of x equals h. Now the axis of symmetry is this vertical line that passes through the vertex, and what it says is that your graph will be identical shaped on both sides of that line. The parabola will open upward if a is greater than 0, and it will open downward if a is less than 0. The graph will be wider than the graph of x squared if a is between negative 1 and 1, therefore if a is a fraction. And it will be narrower than the graph of y equals x squared if the absolute value of a is greater than 1, meaning we don't care if it's a positive 4 or a negative 4, as long as it's greater than 1, the graph will be narrower. So, looking at this one, what all do we know? We know that a is 2, therefore it opens upward. We know the vertex is negative 1, negative 18, or h is negative 1, k is negative 18. We know that the axis of symmetry is x equals negative 1. Okay, the domain, if we look at the graph, the vertex is at negative 1, negative 18. So if we put our parabola on there, the axis of symmetry is x equals negative 1. Now your range goes from negative 18 upward. Now it's decreasing as the graph goes down until it hits the vertex. So it's decreasing from negative infinity to negative 1, and it's increasing from negative 1 to infinity. Okay, let's do another one. If we wanted to graph 2x squared plus 4x minus 16, first thing we're going to do is get our vertex formula. Let's pull out a 2, x squared plus 2x, leave your minus 16 out there. Half of 2 is 1, 1 squared is 1, but that's like adding a positive 2 in here, so we're going to subtract it. So we get 2 times x plus 1 squared minus 18, which is what we had earlier. We know that the vertex is negative 1, negative 18, back 1, down 18. And we know that the graph is a little bit skinnier than a regular parabola. So right now, to sketch it by hand, all we do is we care that it opens upward, and we'll just leave it at that. The different kind of formula, the vertex of the graph of f of x equals ax squared plus bx plus c, can also be found by finding the point where x is negative b over 2a. You plug negative b over 2a back into your function, and that function value is the y value of your vertex. Okay, so for this one right here, a is the number in front of the x squared. B is the number, we'll go ahead and throw in c. C is the number that doesn't have an x. So the x value is found by doing negative b over 2a, which would be negative 4 over 2 times 2, which would be negative 4 over 4. So the x value of this vertex is negative 1. The y value is f of negative 1, which means we're going to do 2 times negative 1 squared plus 4 times negative 1 minus 16. Well, negative 1 squared is 1, so 2 times 1 is 2. 4 times negative 1 would be negative 4, which would give us negative 18, so we know that our vertex is negative 1, negative 18. Same graph as earlier, back 1, down 18, and then we throw in our parabola going up. Now, extreme values. The vertex of the graph f of x equals ax squared plus bx plus c is the lowest point on the graph if a is greater than 0, or it's the highest point on the graph if a is less than 0. Now think about it. If a is greater than 0, that means the parabola opens up, so your vertex is the lowest point. If a is less than 0, then your parabola opens down, so your vertex is the highest point. Such points are called extreme points, or also extrema, or if you're talking just one, it's the extremum. The maximum and minimum values are sort of like the extreme points. For f of x equals ax squared plus bx plus c, if a is greater than 0, the vertex hk is called the minimum point of the graph. Now, the minimum value of the function is k. Okay, now there's a difference. The extrema, or the extreme point, is the entire ordered pair, h comma k. The minimum value is just the y value. Same thing, if a is less than 0, then the vertex hk is called the maximum point of the graph, or the maximum value of the graph is just the y value. So let's try an example. Give the coordinates of the extreme point and the corresponding maximum or minimum value for each function. Well, we look at f of x equals x squared minus 2x plus 3. We know it's quadratic, so we know the graph is a parabola. We need to find the vertex. So we say, well, x is negative b over 2a. We need a, b, and c. So a is the number in front of x squared, which is 1. B is the number in front of x, which is negative 2. And c is 3. So we get negative of negative 2 over 2 times 1, which is 2 over 2, which is 1. You plug that number back in to get the y value. So that would be 1 squared minus 2 times 1 plus 3, which is 1 minus 2 plus 3, which is negative 1 plus 3, which is 2. So we know that our vertex is 1, 2. If you think about the graph for a second, over 1, up 2, it's a positive x squared, so we're opening upward. So this point, the vertex, is the lowest point. It's the minimum point at 1, negative 2. Okay, that is your minimum point. Now the minimum value is 2, because that's how low your graph actually comes. Okay, so your values are just the y values. Your point is the entire ordered pair. Okay, let's do another one. A is negative 1, B is 4, and C is 5. So the x value is negative b over 2a, so that would be negative 4 over 2 times negative 1, which would be negative 4 divided by negative 2, which is 2. Your y value, you're going to plug in 2, so that's negative 2 squared plus 4 times 2 plus 5, which would be negative 4 plus 8 plus 5. Well, negative 4 plus 8 is 4. 4 plus 5 is 9. So in this case, our vertex is 2, 9. So we go over 2, up 9. But now this is a negative x squared, so this parabola is going to go down this way. Now because this is the highest point, we say that the maximum point is the vertex 2, 9. We say that the maximum value is 9 because that's where the highest y value occurs on our graph. Now, let's use the calculator to find the vertex and identify the max or min value. Okay. So what we've got is y equals x squared minus 2x plus 6. I'm going to go back to zoom 6 because I don't remember where we were zoomed out to. So we know it's a positive x squared. This is our vertex. The calculator will actually find the vertex for us. If we go to second, calculate, this was the minimum value, so we're going to choose option number 3. Now, when it's asking us to find a max or a min, it's asking us go to the left and pick a point. Well, see, we're already to the left of the minimum value. Then it asks us for the y value, the right bound. So you make sure you cross over the lowest point, press enter. Then it asks, do we want to guess in between those 2 points? No. So we hit enter. And that says that our minimum value is 0.99999, which I would safely call that 1. And the y value is 5. So the minimum value would be 1, 5. Sorry, that's our minimum point. That is our vertex. Now the minimum value is just the y value, which is 5. Okay, let's try it again. Let's go back on our calculator. So we're going to go to y equals negative x squared minus 6x minus 8. Then we're going to do graph. And there's our parabola opening downward. Here's our vertex. Let's find it. So we're going to go second, calculate. This time it's the maximum number 4. Left bound, we're going to make sure we go over to the left of the highest point. Press enter. Go to the right of the highest point. Press enter. We don't have to guess. Press enter. So the highest point would be negative 2.999, which I would safely call negative 3. And the y value is 1. Negative 3, 1. Now the maximum value, that's our maximum point, or the vertex, and the maximum value is just 1. Now, let's go a different way. Let's find the equation of the quadratic function that has a vertex of negative 1, negative 3, and passes through the point 4, 47. Then it says to write your answer in f of x equals ax squared plus bx plus c form. Well, because they give us a vertex, let's go back and think about our vertex form. Y equals x minus h squared plus k form. We know a vertex, this is hk. We also know a point, this is xy. So if we plug all this in, we get 47 equals 4 minus negative 1 squared plus k, which would be minus 3. Oh, we forgot our little a out here, didn't we? So we get 47 equals, a times 4 minus a negative 1 is 4 plus a positive 1, which is 5 squared minus 3. Adding 3 to both sides, we get 50 equals a times 25. Divide both sides by 25, and we get a is equal to 2. So now we can go back onto our formula and say y equals 2 times x minus negative 1 squared plus k, which is 2 equals 2 times x plus 1 squared minus 3. Now let's FOIL this out. I don't know where that 2 came from. Y equals 2 times x squared plus 2x plus 1, if you FOIL that, minus 3. So y equals 2x squared plus 4x plus 2 minus 3. Or y equals 2x squared plus 4x minus 1. This is the quadratic equation that has a vertex of negative 1, negative 3, and passes through the point 447. Okay, now let's do an application. The table gives data for the percent increase on hospital services in the years 1994 to 2001, where X is the number of years since 1990. Find a quadratic function modeling this data. So we've got 8 different data points. So we're going to go into our calculator, like we did for the linear regression. We're going to go to Stat. We're going to choose option number 1, which is Edit. And we're going to enter X values, 4, 5, 6, 7, 8, 9, 10, and 11. Then we're going to move over to our LT, and these are our Y values. We have 1.8, enter, 0.8, enter, 0.5, enter, 1.3, enter, 3.4, enter, 5.8, enter, 7.1, enter, and 12.0. So once we get all of our data points in there, we go back to Stat. This time we slide over to Calculate. Now because we're looking for a quadratic equation, we come to quadratic regression, or number 5. We press Enter to select quadratic, which tells us that A is 0.3696, B is negative 4.105, and C is 12.144. So it tells us to find the quadratic function modeling this data. So now when we come up here, we say y equals A, which is 0.37. I'm just going to roughly go to the hundredths, x squared, minus B, which is negative 4.11x, plus C, which is 12.14. This would be our quadratic function modeling this data. If air resistance is neglected, the height S of an object propelled directly upward from an initial height of S sub 0 feet with initial velocity v sub 0 feet per second is given by S of t equals negative 16t squared plus v sub 0 t plus S sub 0, where t is the number of seconds after the object is propelled. Okay? The coefficient of t squared, negative 16, is a constant based on gravitational force and will vary on different surfaces. Note that S of t is a parabola because it's a t squared, and the variable x will be used for graphing time t with your calculator. Okay, so here's our problem. A ball is thrown directly upward from an initial height of 100 feet with an initial velocity of 80 feet per second. Give the function that describes the height in terms of time. So, hint is we're going to use s sub t. So, s sub t equals negative 16t squared. That's always negative 16 for these type of problems. Plus, v sub 0 is our initial velocity, which is 80, times t, plus s sub 0. S sub 0 is our initial height, which we're starting at a height of 100 feet. Okay, to graph this function, we're going to do negative b over 2a. So a would be negative 16, b would be 80. So that would be negative 80 over 2 times negative 16, which is negative 80 over negative 32, which would be 2.5. Then we're going to plug 2.5 back in, so we'd get negative 16 times 2.5 squared plus 80 times 2.5 plus 100, which would give us 200. Okay, now we could do this on our calculator. Negative 80 divided by negative 32, which is 2.5. Then plug it in, negative 16 times 2.5 squared plus 80 times 2.5 plus 100, which gives us 200. Or if you would rather do it on your calculator with the graph, go to y equals, enter your graph. Let's start out at our zoom 6, which is not going to show us the parabola, so we can go to zoom 0, which is zoom fit. Now we can see the parabola, and we know that we're trying to find this maximum value up here, so we're going to go second calculate. The maximum is number 4. Go to the left of the highest value, press enter. Move your cursor, and I know you probably can't see it back there behind all those numbers, but it's moving across the top. Make sure you're to the right of the highest point. Press enter. Press enter for guess, and that says that our maximum is 2.5 comma 200. So that's what our graph would look like. After how many seconds does the project reach its maximum height? Well, the maximum height occurs at the vertex. X is the number of seconds, so it takes 2.5 seconds to reach its maximum height. For what interval of time is the height of the ball greater than 160 feet? Okay, what I'm going to do is I'm going to go back and redo my window. Let's do windows from X values. We can leave that one. Actually, we could call it negative 1 to 10. And our Y values, let's just call that from 0 to 300. We just want to include our vertex of 200. So there's our picture. The question says, for what seconds is the ball greater than 160 feet? Well, 160 feet is going to be right in there. So if we went to Y equals a Y2 of 160, graph that. So we're looking for the seconds from here to here. Well, we can find this point. Second, calculate where they intersect. Enter, enter, enter. That gives us the second one of 4.0, so basically 4 seconds. Now let's find the other one. Second, calculate the intersect, which is number 5. Enter for the first curve, enter for the second curve. Now remember, we want to move our cursor back over to the one that we're looking for, and that would be 0.98. So what we've got is we've got x equals 0.92 seconds and x equals 4.1 seconds. So that's when the ball would be greater than 160 feet. Now, after how many seconds will the ball fall to the ground? That's from here all the way to here. And a lot of people say, well, if it takes 2.5 to get to the highest point, wouldn't it take 2.5 to get back to the ground? No, because remember, we started at 100 feet. So what we're going to do is we want to find where this function, where the height is 0. So we're going to say y1 equals the original equation, y2 is equal to 0, because we want to find when it's sitting on the ground. So when we graph that, there's our function. We want to find this one right here. So we're going to go second, calculate number 5, enter for the first curve, enter for the second curve. Let's go ahead and make sure our cursor's over here closer to that one. And we get the intersection is 6.03. So about 6 seconds after the ball is shot up is when it will hit the ground. Now that's the end of chapter 3.2. You're ready to do my math lab on this section of homework.